Hi there and welcome back to Triplicate. And in the last video I put up, I was working on super battery tester charger, and while I was doing that I managed to blow up one of the outputs of my power supply. Now this has the main output. Let's see if we can tip this up. This has the main output, which is 0 to 30 volts, current limited, and it has a 12 volt output and a 5 volt output, both at 500 milliamps, and they are both very useful because although it only really has one main output, most of the time if you want a second power supply it's either 12 volts or 5 volts at not much current. However, I discovered that the 12 volt output at least is not protected when I inadvertently shorted it out. So I have here the meter. We turn her on, so the main output is set to 12.6 or whatever, it's just what it was on. The 5 volt output 4.96, which is all good, and the 12 volt output is nothing. So I thought I would see if I can find out what I've blown up and hopefully fix it. And I thought I'd turn the camera on and bring you along for the ride. Okay, so the model is a Manson EP-603 and I've had it for probably at least 15 years. So I thought I'd Google it, see if I can find any information and try and get a better date on when it was made, and I discovered they're still making them. So that's the manufacturer's website, and there it is. It's the same one, it's still available, and Rapid sell it under their own name, but it's obviously the same unit, looks exactly the same, and it's £124.45 including VAT. I think I paid about half that for it. But anyway, there it is. And while we're here, I did try and find a schematic for it, but I failed, so we're going to have to try and work out what's going on ourselves as we open it up. So shall we do that? Okay, so judging by the stickers on the top, it's at least 2 computers old. Right, I guess screws, more screws and screws. We get this top cover off. This thing is my ground wire, it takes it grounded too. It remains ground, so that is my ground wire. Okay, this should lift off, and it does. And what have we got in here? Lots of stuff and lots of dust. Okay, so there is a circuit board. Show you that, which seems to have all the controls and the meters attached to it. There is a transformer there, a nice big transformer. There is another board here which has at least one big electrolytic on. Oh, and there's so much dust. Oh, you see a couple of TO3 power transistors down there and some more transistors with heat sinks on there. So perhaps what we should do is try and get this heatsink and assembly off and see what's going on under here. Hopefully it's these 4 screws. Oh, I didn't know what happened there. I burnt at some point. Come on, out of there. Grab it. Oh, there we go. It'll tip over that way, so I put it on that edge. Right, well, I am going to have a look over this and see if I can find any obvious burnt looking components. Since I think I forgot to say, oh shit, they're covered in dust, that when I short circuited there was a little plume of smoke came out of the top, so there should be something somewhere obviously burnt. Okay, so I've taken it apart a bit more. I've dropped the front panel off and its associated circuit board. So these are the terminals for the 12 volt output, which are soldered on the board there. So they are connected to this little guy, this TO220, which don't think you can see on the camera, but that is an L7812CV, which is just a standard 12 volt regulator. And let me attempt to support this somehow. So I have my meter in continuity mode. So this is the output, which is connected to the output pin of the regulator, and that is the ground, which is connected to the ground pin of the regulator. And the input pin of the regulator comes from the main unregulated supply. Can you see that? Supplied by the transformer through the bridge rectifier and smoothed by the big capacitor. And there's only one unregulated supply, so we know that works because the main output works. So somewhere between here and here something has failed. Now I am going to very carefully turn it on and we will see what voltages we can find where. Okay, so here we go. Now firstly let's have a look across the output, and we know there's nothing there. So we're now going to have to try and hinge this up again. I shall just turn it off. Okay, so I've sort of supported it. turn her on again, we want to know if there's anything coming into this regulator. Now, I didn't mention, again it doesn't show up on camera, but the regulator doesn't look as though it's got hot and burnt. And no, there's nothing coming into the regulator. Well, a few millivolts. Oh, suddenly 20 volts are coming into the regulator. Well, there you go. So it does look like the regulator has failed, which is odd because it doesn't look burnt, and something burnt up, something threw smoke out. "20 volts in and a few millivolts out." Okay, right, well, to get the regulator out I think I'm going to have to pull the circuit board off. So, right, so I think this is held on with the two nuts that hold the two main terminals on for the main supply, and these two screws over here, and I can't see anything else yet. So to get those off I shall use the proper tool. Too tight. There we go. And screwdriver, where I've done that. Alright, is that it? Is she gonna come off? Doesn't seem keen. Okay, there are two more screws lurking down little holes there. Can't think of anything else, so shall we have a go at those? They're going to be fun to get back in. How about that? They seem to be undone. Nope. The bottom of the board is so. Right, if we look down here, there are two little can you see that? Screws and washers holding, I think, the meters in. So I'm guessing the meters, the connections are soldered to the board. Oh, they're going to be real fun to put back in. Right, and what about now? So I have I've pulled the pads up. Right, well that just makes it a little more difficult. Anything else? Do I need to take... Alright, we'll pull the knobs off. How about that? Just That side free, the bottom free. I'm going to pull that heat sink. I think it's going to come. Oh. Right. Well, it seems that the meters, okay, they were secured in by screwing a washer over the edge of the meter there, and it seems they're secured the same at the bottom. So the meters must have been put in, the board put on, and the meter terminals then soldered. So I'm going to have to get all the solder off those, or heat all four of those up at the same time, to pull the board off. So that is going to be a pig to do. So what I am proposing to do in the end is to try and pull the regulator off from this side of the board and see how we do with that. So firstly I am going to pull the heatsink off. This should now just come off. It's not actually glued on, no, there's some, I don't know, looks like silicone at the bottom. We've got that off. Let's see if we can pull this gloop off. Yeah. This is going to come off. Yes, I was supposed to put an heatsink for it now, but I can't imagine it would be any good at all. I'm going to move it. Well, it's stuck to the board well enough. Put the guns in, there we go. Okay, got that gunk off. Now by the way, the tracks are pulled up. I sort of think this might be a single-sided board, so it's not actually soldered through the other side to hold it down in place, which in a way makes our job easier here, because we only have to get the solder off the tops there. So come on. There we go, out she comes, whoop, and on the floor she goes. Okay, so I am lucky. I have a little bag full of 12-volt regulators which I got to build a regulated power supply for my power amplifier, and haven't got around to, of course. However, 12-volt regulators we have. So we now need to get all this solder off the board, which we will use our desolder braid. Ow, that's hot. Good, let's get into the hole. Come on. Oh, and there goes a bit of the track. So we've got the old one out, and that track, the hole is there and the track's broken off there. This track is flapping about, that one thankfully goes through and is okay. So we have to reassemble this with some care. And there's a hole there, I wonder what went in that hole. Oh dear. Right, well I'm hoping there was nothing in this hole. I don't think there was. So what I am proposing to do is pull the centre leg back and into there. So it'll give it a bit more strength. And so we want to cut the legs off. It didn't look like the legs went through the holes very far. Get it the right way around, yeah. Out of shot, of course. Okay, so unfortunately the memory card ran out on the camera as I was soldering it in, so here it is soldered in. And are we going to just power the thing up and hope it works? So this is the plug which I am plugging in over here. Turn her on. Well, it doesn't emit smoke, so if I'm going to have to zoom you out, so the meter's in shot. If I plonk the negative probe on the negative and look on the positive, yes, we get a nice 12 volts. So that's a fix. Well, I don't know, the chip doesn't look burnt, but it's just gone pop, so something somewhere else on the circuit emitted smoke but didn't actually burn out, so work that one out. Anyway, so we need to get the heatsink back on and all these screws and bits and pieces back in, which I will spare you and do off camera. Okay, so here it is. It's not completely back together. I thought I'd just give it a test before I finally screwed the case back together. So this is the main output. We turn her on. So it's set to something like 12 volts, and this is a, I don't know, 5 watt, 12 volt spotlight, and there we go. You see there's plenty of light out of that. So I've got a couple of wires in the 12 volt that we've just fixed. So I'm not sure that shorting the two outputs together is a good idea, and may even be what blew it. So here we go, there we go. 12 volts coming out of there nicely. Make sure they're separated. So that's it. I think we'll call that a success, call that a fix, and I will screw it together off camera because that's not very exciting to do, never mind to watch. So there we go. It's a good one. Oh, well, that's it for this video, and as I say, a success. We successfully repaired the power supply. So before I go, actually, I'd like to mention the YouTube channel of a guy called Tim Hunkin, who's an engineer who's been about for an awful lot of years, and sort of, I think, almost invented the sort of YouTube style that I operate, of somebody just doing what they enjoy doing and not being a slick TV presenter or anything. And his original Channel 4 series was called The Secret Life of Machines, and you can still watch them all on his YouTube channel and in other places. And they're really interesting and an insight into the way technology was back in the day. And now he's got a new YouTube video series out on the components, sort of some electrical, electronic and mechanical that make up his machines, and he makes fascinating arcade machines. So that's that. So I think on that note I will say goodbye for this one. So subscribe, I'll leave a comment, and that's it from me. So it's goodbye from Triplicate, home of interesting electronics. Goodbye.